and regression and terms used in the regression model and prediction model, and we'll also get an idea about confidence interval and prediction interval, and then little case study, right? Some simple case studies. So regression is nothing but quantifying the relationship, understanding the nature of relationship and quantifying the strength of the relationship. And see here in my slide, I have shown you 3 graphs, right? And these are called a scatter diagram. You know what is a scatter diagram? It is one of the 7 basic quality control tools. You can think of using a scatter diagram if both your x variable and y variable are of continuous type. Like for example, the height and weight. I want to know whether there is a relationship between your height and weight, right? And both are continuous variable, and now you can plot a scatter diagram. I want to understand the relationship between the speed and mileage of a vehicle. That's a what you call as I can think of using a scatter diagram. I want to understand the relationship between the composition of the material and the strength of the material. These are all situations where you can use the scatter diagram. And if you look at here, there are 3 scatter diagrams. Look at the third one. There is an x-axis. In the x-axis, the variable represented will be known as predictor variable. In the x-axis, the variable that is represented will be known as predictor variable, and the y-axis will be known as the response variable. And what are we trying to do? We are trying to understand the nature of relationship that may exist between x and y. And see, I continuously change the x variable and noticing what happens to the y variable. And accordingly, the value of the y are plotted here. After plotting, when I look at the graph, I could understand the y is completely scattered. Isn't it? Y is completely scattered. When the y variable is completely scattered in your graph, it's an indication that y do not depend on the x variable. Isn't it? Y do not depend on the x variable, which means there is no relationship between x and y variable. When there is no relationship between x and y variable, you can conclude that there is no correlation between x and y. On the other hand, look at the first scatter diagram. See here, I continuously increase the predictor variable, which is the x variable. Look at the way the y variable is changing. The y variable keeps on increasing, am I right? And now there is a relationship. And moreover, I could also see a pattern. The y variable is moving along a perfect straight line. And so I will call this relationship as positive relation. Increase in x causes increase in y. So this is a positive correlation, and moreover, the correlation is strong correlation. Why do I call it strong correlation? All the points lie perfectly on a straight line. Then that's the time I will call it as strong positive correlation. Come to the second diagram, second scatter diagram. As I increase the x, what happens to the y? Y is decreasing. And now this is a case of negative correlation. This is a case of negative correlation. However, look at the pattern. It's a perfect straight line. So I will still call it as strong. Now the correlation is strong negative correlation. Hope all of you are with me on all the 3 graphs. Am I right? The third graph, no correlation and also no relation. The first graph, strong positive correlation. Second graph, strong negative correlation. Please note, correlation measures the strength of linearity, right? And this idea is very important when you actually start using the regression. When you are trying to develop a mathematical model of your problem, this idea is very important. And scatter diagram is one of the 7 basic quality control tool, which you can always think of using it whenever you know that your x and y variable are both are of continuous type. Now moving on. See here, whenever the points lie perfectly on the straight line, we consider the relationship as perfect linear relationship. See here, at that point of time, the Pearson correlation coefficient. Actually, there is a coefficient which will measure the strength of relationship. And here is the formula. And see here, when you have x and y variable and a set of x and set of y, calculate x bar, which is the average, calculate y bar, which is the average of y. Sx means standard deviation of x data. Sy means standard deviation of y data. X means individual x value, y means individual y value, n is the number of pairs of data. Now you substitute this R value. Now you substitute all the values in the formula. You will get the R value. Why is this formula required? Again, like the previous discussion, when you have got a very good eye, looking at the scatter diagram, you can comment on the correlation, whether it is strong or moderate or weak. Suppose if you have certain issue or if you are not able to judge on the relationship by looking at the scatter diagram, then you can use the formula. The formula which is called Pearson correlation coefficient. And look at the guideline for judging the relationship. Your Pearson correlation coefficient will range between +1 and -1. +1 means strong, positive, perfect correlation. And -1 means perfect, negative correlation. 0 means no correlation. And from 0 to 0.4, the relationship is considered weak or the correlation is weak. 0.4 to 0.7, the correlation is moderate. 0.7 to 1, the correlation is strong. Similarly, on the other side, right? Now I'm going to show you one more scatter diagram. Look at the scatter diagram. The x-axis is calorie consumption. Nothing but what you consume, right? How much calories you are consuming. If you consume more calories, what will happen to your weight? You keep on consuming more calories, your weight will keep on increasing, isn't it? And that is what you are seeing here in the relationship. Now looking at the graph, use your eyes and tell me whether the relationship is positive or negative. And also tell me whether the relationship is strong or moderate or weak. Come on, go ahead, please.
The relation is strong.
Very good. Relationship is strong. Then
Positive.
positive. Beautiful.
Positive.
Yeah, all of you are able to judge correctly now. You are saying that the relationship is positive because as X increases, Y also increases. You have noticed it. You are saying that the relationship is strong because all the points you see, the blue color dots, are close to the red color line I have drawn. The red color line I have drawn is called the regression line. The equation of which we will understand in the next presentation about regression. But now the points, approximately lines up along a line, and so you called the correlation as strong correlation. That means this factor is critical to your result. This factor is critical to your result. See how a simple graph is helping you. You just plotted X and Y variable in a graph sheet, and looking at the way the points are getting aligned and looking at the pattern, you are judging on whether the factor could influence your result or not, right? Now we are moving on. And now first case, one more case, and it's again a small exercise, all of you can participate. Now looking at the graph, tell me what kind of correlation it is. Is it positive, negative, strong or weak?
Positive.
Strong and positive.
Positive, strong.
Strong, positive. And those of you who have problem with saying that it is strong, positive, you can look at the Pearson correlation coefficient value. How much is the value here?
0.917.
917.
0.917 means strong, or even you can say very strong. Now this one, second graph. Now what is the relationship now?
Negative.
Negative,
Negative
strong.
strong, sir.
Negative, strong. Very good. Strong, positive, strong, negative. Now what is the relation?
No correlation.
No correlation.
Are you sure?
Yes, sir.
Yes, sir.
I would say it is weak positive.
Weak positive.
The trend is somewhat you can see points are moving upward, and this one is weak negative. See, only to avoid this kind of confusion, we have the R value, isn't it? Whenever you are in confusion whether it is correlation exists or not, now the option is look at the R value. What is R? Pearson correlation coefficient. Now in this case it is for third one is weak positive, the fourth one is weak negative. Now the fifth one, weak positive, weak negative. Now the fifth one. Now looking at the scatter diagram, can you tell me, is there a correlation between X and Y?
No, sir.
No, sir. No.
Now you can say no correlation because it is completely scattered. You can't judge whether Y is varying according to the X or not. So this is a case where you can say no correlation. Now I am showing one more. Now tell me, do you see any correlation between X and Y here?
No, sir.
There is, but
Where-
what you say,
Yes.
there is a correlation.
No
but
correlation.
Exact.
Sometimes
I'll help you now. The fifth diagram, there is no correlation. No correlation as well as no relationship. But the sixth diagram, there is no correlation, but still there is a relationship. Because correlation measures only linearity. There is no linearity here, but I could see a curvy linearity, isn't it? I could see a curve. So don't use the word no relationship, but you can definitely use the word no correlation. That will be confirmed with the R value, lower R value or R value close to 0 or exact 0. But looking at the scatter diagram, I understand the relationship is parabolic. See, again, this first information comes from the scatter diagram. Scatter diagram is working like an FIR. How the FIR, police department is using. You are using the scatter diagram. So what kind of relationship your X has got with the Y? You are getting the initial clue from the scatter diagram. So scatter diagram is one of the 7 basic QC tool. However, the R value will let you understand the strength of linearity. Since the R is 0, linearity, there is no linearity. Hope it is clear to all of you. All right. So, and let me just take you through a small exercise now for the correlation, and then we'll move on to regression. A very small exercise, not that difficult. So calories consumed. I'm just opening my Minitab file for that. Okay, so when can we go for correlation? When both our X variable and Y variable both are of continuous type, right? When both are continuous, we can conduct the correlation study. So I got the Minitab file opened. Sharing the Minitab screen. Please confirm if you can see my Minitab screen. Am I right?
Yeah. Yes, you can
See here, there are two variables. One is weight gain, another one. Yeah. One is weight gain, another one is calories consumed. Can you please confirm which is X variable here and which is Y variable here? Which is X variable, which is Y variable?
Calories consumed.
The first one is Y variable.
Weight gain is X.
You mean Y variable is weight gain?
Yes.
Yes, sir.
Very good understanding. Weight gain. And the X variable is calories consumed.
Calories.
Beautiful. You are thinking, in the right direction. Because only by controlling the calories, you can control your weight gain, right? And that's the idea. And now let me go for, the scatter diagram first. Graph, scatter plot. Graph, scatter plot. A simple scatter plot. I'm okay with simple scatter plot. And Y variable is weight gain. X variable is calorie consumed. I'm giving okay. We all understand how scatter plot is developed now. You can do it manually or you can do it in this simple manner. In few clicks, few seconds, you have, the graph. And looking at the trend of the point, do you notice the points are continuously going up? Positive relation. And moreover, it is almost a straight line. And I will also say the relationship is strong. In order to make your decision easier, you can also go for a scatter plot with the line, with the regression line. Give OK. And once again, Y variable is weight gain, X variable is calorie consumed, and then you just give OK. Do you now see? You have the regression line also visible. But understanding about this particular line, the subject is called regression. But now this is only telling you that, the relationship is linear. And now let us minimize this graph. And this area is called, session window. And now when you do actually, any statistical analysis, the statistical report will come in the session window. Graphs will come, will pop up in this manner. Now let me do the correlation study. Go to stat, go to basic stat, go to correlation. Go to stat, go to basic stat, go to correlation. See here, automatically it explains. Measure the strength and direction of the linear relationship between two variables. Click this. And now Minitab is asking you, what are the variables? The variables are column 1, weight gain, column 2, calorie consumed. You select both. And now Pearson correlation coefficient. There are different coefficients exist. We have learned Pearson correlation. Select that. Display the p-value. Of course, we always require a p-value and then give OK. Now, correlation study is conducted. Look at the Pearson correlation coefficient value. How much it is?
0.9.
0.9 means it is
Near to 0.
very good.
Near, sorry, 1. So it's strong positive.
Strong positive.
Strong
positive correlation. Now, what to do with the R value? See, your study is confirmed by a lower p-value. You are saying that there is a relationship. You are saying that there is a strong relationship and that is confirmed by a lower p-value. Actually, when you are doing correlation, your null hypothesis is there is no relation. Do you understand? Your null hypothesis is there is no relation. But in this case, since p-value is less than 0.05, what should you do? You should reject the null. Am I right? When you reject the null, what does it mean actually? When you reject the null, it means there is a relation, isn't it? There is a relation. There is a relation means the factor is critical, isn't it? There is a factor is critical. If the factor is critical, how much is the influence? That also I want to know. How much is the influence? You understand how the sequence of analysis, what we are doing. Now, in order to understand how much is the influence, I want you to calculate something called coefficient of determination. What is this? Coefficient of determination. Coefficient of determination is nothing but R square. What is R square? R into R. What is R value? 0.97. I have to multiply it once again by 0.97. Can you help me with the value? 0.97 into 0.97. Am I correct here? 0.97 into 0.97. Am I correct here?
Yes, sir, you're correct.
Very good. Now, this coefficient of determination is telling me the influence of X on your Y is 94.09%. Do you understand how this calculation is helping us? The influence of the X variable on the Y variable is 94.09%, which means if I control this X variable, 94% of the problem can be fixed. Do you understand?
Yes, sir.
You understand? With Y variable can be fixed. It is something like, husband getting influenced by a wife. In many families, husband, they take decision according to the wish of the lady in the family. Am I correct or not? Yes or no? All of you are doing like that only. Am I right?
Yes, sir.
So the influence, what is the percentage of influence your wife has got? 94%. You rarely listen to others. Most of the time you listen to your wife only. Similarly, this particular Y variable, which is the weight gain, listens 94% of the time. It responds only to the calories you are consuming. Very rarely the weight gain depends on the other factors. Maybe your sleeping pattern, maybe your exercising pattern, maybe your stress level and all these things. Please note, all these conclusions are applicable. All these conclusions are applicable only to the population from where the data is collected. Am I right? Am I correct or not? Come on, guys. Do you understand the statement? Whatever conclusion I have told you, this conclusion is true only for the population from where the sample data is collected. Where from the data is collected? We have collected data from an individual called X, or let me say not X, from an individual called Mr. Ramesh. So the calorie consumption pattern and weight gain pattern of Ramesh is studied, and all your conclusions are now applicable only to Ramesh. I cannot apply this understanding to help Gurmeet because the data is collected from Ramesh. If I really wanted to help Gurmeet, I should study Gurmeet body behavior, isn't it?
Yes,
I will advise Gurmeet to consume 1,000 calories for 1 week. I will see what happens to the weight. And if there is a weight gain, I will record it. And again, another 1 week, 1,200 calories. This is how I must study. And this is called inferential statistics. Based on the sample, I judge the characteristics of the population. Hope so far is clear to all of you. Am I right?
yes, sir.
Very good.
Yes.
So now we move on to regression. Yeah. So again, I'm sharing the screen. Yes, this we have finished. Yeah. So what is regression analysis? And I think, yeah. So what is regression analysis? Regression analysis is nothing but, deriving the mathematical equation. Regression analysis is nothing but deriving the mathematical relationship that exists between your x variable and y variable. Regression can also indicate direction of relationship. Correlation also indicated, isn't it? Now regression also can indicate. Then what is the advantage? Correlation can study only the linear relationship, but regression can help you to study both the linear as well as non-linear relationship, right? And all analysis comes with the statistical significance. You know what is statistical significance? The p-value. Can I trust the data or not? I will decide based on the p-value only. And then the derived regression equation can be used as a prediction model. Only when you have a strong regression equation, simulations can be developed. Till then, your mathematical model is not ready for prediction. You might have seen certain software simulating the conditions. The software works based on the regression equation in the background. Only when you can generate the regression equation properly with the higher R square value, higher adjusted R square value, higher predicted R square value, the regression equation can be used as a prediction model, otherwise not. And all regression uses a method called principle of least square. And let us understand all these things. Terms used in regression analysis: regression model, regression equation, and then regression coefficient, and then residuals. And all these things we are going to understand. Regression model. There are different models exist. For example, regression model can be linear, regression model can be quadratic, regression model can be cubic, regression model can be higher order. When I say regression model is linear, the x will be raised to the power of 1 only. In your regression equation, you will only find the x terms involved, not the x squares and higher level. When I say the regression model is quadratic, you will not only see x terms, you will also see x square terms. When I say cubic, you will see x cube also, and then higher order, right? And we will see all these things one by one. See here, linear model. When will you go for the linear model? When your scatter diagram is appearing like this. Do you understand? We derive the information from the scatter diagram. When the scatter diagram says the relationship is linear, that's the time we go for the linear regression. And see, look at the regression equation. Look at the regression equation. It is in the form of y equal to mx plus c. All of us have studied, isn't it, in the basic mathematics? Y equal to mx plus c is the equation of the straight line. Isn't it? Equation of the straight line. Yes, it's a basic equation where m is the slope of the curve, c is the y-intercept. Isn't it? M is the slope of the curve, c is the y-intercept. But what I have written is ax plus b, which means a is the slope, b is the coefficient. And if you have only one x variable involved, it is simple linear regression. When you have more than one x factor, see the second one, x1, x2, and now it is called multiple linear regression. All of you are with me on what is linear regression? All of you are with me on this?
Yes, sir.
Very good, right? But see, both are linear regression, but the first one is simple linear regression. Second one is multiple linear regression, because multiple factors are involved, but all the factors have only linear relationship. And this is called regression of model order 1. On the second one, quadratic, look at your scatter diagram now. Your scatter diagram has got a quadratic nature, isn't it? And now is the time you should go for this kind of equation. A second degree equation, y equal to ax squared plus bx plus c. Now look at the model order. Model order is 2. And again, the input comes from scatter diagram, and accordingly, I am generating the regression equation. Model order 3, look at the scatter diagram. Your curve is going up, coming down, again going up. That means ups and downs you are able to see. And that means it's a cubic equation, ax cube plus bx squared plus cx plus d. This is called model order 3. This understanding is important. Then only while generating the regression equation, you will know which model order will be a best suit. Only when you generate the regression equation properly, simulation is possible, prediction is possible, and otherwise because we develop the regression equation only to predict the future performance. All right. And now just to help you further understand the model. See, for the same problem, calories consumed, and the y variable weight gain. And see here, this is the thing. And the regression equation Minitab has developed. I'm going to show how Minitab is generating. See here, weight gain equal to minus 754 plus 0.4631 calories consumed. It is of the order y equal to mx plus c. Now, what is the value of m in the equation? What you are seeing? The value of m is 0.4631. This has got a meaning, I'll tell you. And value of c is minus 754. Right? And when I see m equal to 0.4, it means when I increase the calorie consumption by 1 unit, the weight gain will increase by 0.46 unit. How many of you understand my statement now? The m value tells me what will happen to the y for every unit increase in the x. When I increase the x by 1 unit, how much unit y will increase? 0.4631. How do I know it? Looking at this coefficient. This coefficient is called regression coefficient. All of you understand the purpose of regression coefficient? Can I get a yes here?
Yes, sir.
Very good, right? So what will happen to my y? Or in order to increase my y, what should I do? I'm telling you, increase your x. How do I say? Look at the symbol of the regression coefficient. It is plus. That means positive correlation. And the how much will be the change in the y? This number is telling me. And this minus 754.6 is called the y-intercept. Nothing but the c value. In order to get the y-intercept, you extend the line. And find out the point where your y is, where your line is crossing the y-axis. Let me take my pen and then I will draw it for you. And see here, I'm extending it. I understand my line is crossing the y-axis here. And this point is below 0. Am I right? Below the origin. Yes. And that is why, it is negative. But you don't have to really do all this painstaking process. You just feed it in the Minitab or Excel and that will generate the graph for you. But you should be able to understand the statistical report. Now you understand the line is passing through the y-axis at a point which is minus 154.6. And every unit increase in the x will cause 0.46 unit increase in the y. Hope it is clear to all of you. And also, you can generate this complete equation yourself. You can generate this complete equation yourself. For example, let me tell you how this 0.4 comes. What is m? What is our understanding? We all studied max, in the graduation as well as school. What is m? M is slope. Am I right?
Mass.
M is not mass. M is slope. M is slope of the straight line. Slope means the angle it makes with the x-axis. How much is the angle it makes with the x-axis? This is the angle. Can you use a protractor and measure this angle? Is it possible? Possible or not?
Yes, sir.
Possible. So measure this angle, find out the tan theta. This is one method. Measure this angle, find out tan theta. This is one method. Another method is you draw a horizontal, draw a vertical wherever you want. This length of this vertical line is del y. The length of this horizontal line is del x. Find out the del y and del x. You can see here del x is almost double del y. Am I right? Del x is almost double del y. And that's why you are getting this 0.46. Do you understand how this 0.46 is coming? Measure the length of y, del y, which is actually some value and divided by del x. Actually, what I'm doing again is I'm again calculating tan theta, because what is tan theta? Opposite side by adjacent side. What is opposite side? Your del y. What is adjacent side? Your del x. Do any method, you will definitely get this, right? This is called regression coefficient. Hope it is clear to all of you. Am I right?
Yes, sir.
So regression helps you to understand the direction of relationship. How do you understand the direction of relationship? Look at the sign in the regression coefficient. If the sign is positive, the relationship is positive. Size of the relationship. Look at the value of your regression coefficient, 0.46, right? And based on which you can understand the size of the relationship. So this we have discussed. See here, the coefficient will represent the change in your response variable. All right. See, this is another example, simple example. Look at this line. I increase x by 1 unit. Y increases by 1 unit. Am I correct here? I increase x by 1 more unit. Y increase by 1 more unit. That's why you are getting this point. Am I correct?
Yes, sir.
That is why the equation is y equal to y equal to x. What is the value of regression coefficient here? 1. Am I right? Increasing x by 1 unit will increase y by 1 unit. In the place of 1, if I have 0.46, what will I say? Increasing x by 1 unit will increase the y by 0.46 unit. Now come here. Increasing the x by 1 unit causes y to increase by 2 unit. Am I correct? X is increased by 1 unit. Y is increased by 2 unit. Now what will be the equation of this straight line? Can somebody make a guess? Y equal to? Come on.
2 we are using, yes, 2.
That's all. Y equal to 2x. Looking at the equation, you can comment very well on the relationship. Here I am not adding any constant because the constant is 0 here, isn't it? It is passing through the origin. So I don't require this here. So simple mathematical tool, but helping us, in our decision making. And always when you actually do regression, there is something called residual is possible. Look here, the red color dots are the actual values of y variable. But instead of using the actual values of y variable, we consider this blue color line for developing the regression equation. If you look at the blue color line is actually, at a distance from all the red color point. The distance of the blue color line from the point is called residual. This residual will dilute your prediction. So see to that you draw the line in such a way that the residual is minimum. Suppose if I draw the line here, do you think this will be a best regression? No. The points are too far away from the line. I cannot draw the line here. I draw the line in such a way that the residual is minimized. This ideology is called principle of least squares. This ideology is called principle of least square because I have the deviation on the positive side. I have the deviation on the negative side. The sum of the total deviation, sum of the square of the deviation should be minimum. That is called the principle of least square, and thereby your regression equation can better speak the reality, right? So residual is the difference between the observed value and the fitted value. Fitted value is the point on the blue color line. The red color points are the observed value. The blue color points are the fitted value. If there is a difference, that is called residual. Residual can be positive, residual can be negative because you are seeing almost approximately half of the points above the line, half of the points below the line, and so you will have both positive and then negative, right? So now see here how to do regression for this particular case. Same problem, calorie consumption and weight gain, right? And I plot the correlation study. This we have discussed. 0.97, R squared is 0.94, all that we have discussed. Now what I want is, I want you to develop the regression equation for this. See here, Minitab has generated the regression equation and we spoke about it. And whatever your conclusions, that is confirmed with the lower p-value. Look here. And look at the R square. The R square is very important. The R square is 94%. This is what we also understood. By multiplying the R value, we got the R square value. When I get R square value of 93, it means 93% of the changes observed in the Y variable are due to the changes I have made in the X variable. So R square talks about the strength of the relationship, talks about the influence of the relationship, right? So now whenever you see R square more than 80%, you can understand that factor is the single root cause. Do you understand my point? Whenever R square is more than 80%, that factor is the major influencer. The number of root causes are only one, because 80% of the problem comes only from a single factor. If R square is not above 80%, let us say R square is only 30%. What does it indicate? The strength, the influence of the factor is
Very less.
very less. That means other factors are also involved. Now I will question you. Since your R square is only 30%, I will ask you why you have not included the other factors. Now what went wrong? You have not done the analysis properly. probably in the brainstorming, probably in the fishbone analysis, people have not thrown proper light on, the proper X factors. Do you understand? If you have considered all those factors properly, that could have appeared in your regression. But if they don't appear and your R square is 94, then it is all good. But you have considered only one factor, but the R square is only 30%. It means you have to go back, conduct the brainstorming and find out the missing factors, do the hypothesis testing, come back and add here. If you add the additional factor, R square will improve. If you add an additional factor along with the lower p-value, adjusted R square will improve. So adjusted R square is a superior tool than your R square. When R square talks about the strength of the relationship, adjusted R square will talk about the purity of the relationship. Both are important to us. We need the strength. We also need purity. So when you frame a regression equation, look at both the R square. Look at both the R square, and if both are more than 80%, you are analyzing properly and you are driving your team in the right direction. You are close to generate the results from your project. This is what you can infer. Is it clear to all of you? R square? Yes?
Yes, sir.
Very good. So, and always, when you do any regression analysis, this kind of report will come, and we are interested in this. We wanted to have, more than 80% or 90%. And now you see here, there is a confidence interval, 95% confidence interval, and there is also a prediction interval. If you look at the prediction interval, it is very wider. It is wider. See here, it varies from 107 to 240. 107 to 240. But if you look at the confidence interval, it is not wider, it is little narrower. Because confidence interval, in order to arrive on the confidence interval, we use the mean value. We use the mean value, which means if you, when I say, see here, actually, calorie consumption, see here, I'm giving in my regression equation, I am giving calories consumed is equal to 1850 calories. How much will be the weight gain expected? Minitab is telling me, my mathematical equation is telling me 102 grams weight gain you can expect. Look at this 102. This 102 is within the confidence interval. Within the confidence interval. So for calculation of the confidence interval, what I will use is, I will use the mean value of my study, mean value of my experimentation, plus standard error, right? So this is called the standard error of mean. So the standard error of mean is actually a ratio between standard deviation of the sample and divided by the square root of the sample size. So what happened? I get standard error of mean as 24. This 24 is added with the mean value. See here, 102 plus 24. Actually, what is our understanding on the normal distribution? Plus or minus 3 times the error. So find out the standard error, multiply by 3, add it with the fitted value, then you will get this confidence interval. Similarly, this confidence interval. So confidence interval is calculated using the mean value of your sample study and the standard error in your sample study, and probably the calculation part of it we'll discuss later, right, at a later stage. So what is that we learned here? Regression is a technique to generate the mathematical equation describing the relationship between X variable and Y variable. As a Six Sigma team, you can make use of the regression equation to investigate the relationship, and if the predicted R square also is at the higher side, you can use the regression equation to predict the future results. Regression indicates direction, size, as well as statistical significance. It comes with the p-value. The regression coefficient will help you to estimate the change you will observe in your Y variable for unit increase in the X variable. So regression can be used to model linear relationship, quadratic relationship, cubic relationship, or relationship of any higher order, and that information is derived from the scatter diagram. Hope the learnings are understood properly. We'll also see how we can do the regression in Minitab quickly. So let me show you my Minitab screen. Hope it is visible again, my Minitab screen. Am I right? Yes or no? Is my screen visible?
Yes, sir. Yes, sir.
Yes, sir.
Yes, yes, yes.
So now let us go for the regression, right? Now you go to stat, go to regression, go to fitted line plot, stat regression fitted line plot. Now response variable, which is response variable? Weight gain. Which is predictor variable? Calories consumption. Now there are three options: linear, quadratic, cubic. Which one you want now for calorie consumption and weight gain?
Linear.
Linear. Don't go for quadratic now because you have seen the scatter diagram, right? So give the linear and give OK. And now the regression equation is generated and the regression graph is generated. Regression line is visible. Equation is available. Minimize this. Go to the session window. See here, regression model, regression equation is available. Model summary is available. What is your R square? 94%. Adjusted R square also close to 94%. R square and adjusted R square, if they are close to each other, it means you have developed a very good regression model. And looking at the regression equation, I could judge that you are moving in the perfect direction towards producing the result. What is your understanding here? Calorie consumption is the biggest source for the weight gain that is observed in the particular person. Same way you can deal with any kind of X and Y variable and then you can interpret the report. Hope it is clear to all of you. If there are any questions, please feel free to ask. I'll be happy to answer.
Sir, is there